Hey everybody, this is Matthew Doyle for Autodesk. Welcome to Lua Tips and Tricks, Episode 3. In this episode, we're going to continue from Episode 2, working with the VR camera inside of Stingray. And if you remember from the previous tutorial, we basically covered using an animated mesh object like a roller coaster cart to simulate the camera. In this episode, we're going to look at two other techniques. We're going to look at how to use a camera that's already been animated in 3ds Max or Maya. In this case, we're using 3ds Max, and then importing that animated camera and using it as your VR camera. We're also going to look at using a Stingray camera and animating it with the story system in Stingray, and then using that as your VR camera. Now, I'd strongly advise you, if you haven't seen Lua Tips and Tricks Episode 2, to watch that first, because it goes into more detail on some of the lines of code we're going to be writing. I don't go into as much detail this time on those lines of code because a lot of them are repeated. There are some subtle differences, however, in the code, as well as in how you bring the camera in. So I hope you enjoy this tutorial. It will be the last in this series on using the camera in VR. And yeah, so we'll see you in the tutorial. Here inside of 3D Studio Max 2018, I've gone ahead and imported parts of the roller coaster track. Not the entire thing, because this is just a demo, but I've imported some of the roller coaster track in the cart, and I've created a free camera and given it some animation here. So this is a standard 3ds Max free cam, and it's got 90 seconds of animation just kind of following the track. All I have to do now with this animated camera is export it as an FBX file. So we'll go to File, Export. I'm going to export it here, and we're going to call this Animated Camera. In the export information here, we just want to make sure that we're actually exporting the cameras. So we have a check mark there under Cameras, and we'll just hit OK. All right, so back inside of Stingray, and we're using Stingray 1.8 this time. We're going to import that camera. So I'm just going to go to my Content folder. I have a Cameras folder, and then we would just go to Import and bring in the animated camera.fbx. Now in the import dialog, we don't really need everything. We can turn off materials, we can turn off textures, we'll leave unit mesh turned on, and make sure that cameras is checked. We also want to make sure that animation is checked. We're going to create a new or update a skeleton for our animation, and the skeleton name should be animated camera. We'll go ahead and import clips, and we'll create an animation folder and hit import. Now I've already imported mine. I've already created an animations folder. There's the animation clip. And of course, we have our unit and the animation skeleton, which is created a joint system for the camera animation that will be centered at the origin of the world. So we'll go ahead and drop this camera. We're going to select the camera unit, so animated camera unit, and we'll just drop it into the level here. And we want to make sure, remember, it creates a joint system that's centered at the origin of the world. So we're going to set the translate to 0 for X, Y, and Z. All right, so now we should see our gizmo here at the origin of our level. Just remember the name of the camera here is Animated Camera. We also need to remember the name of the node. So the node here is Camera 001. This is the name from 3ds Max. If we were to select the camera, go to the modifier panel, you can see here the camera's name is Camera 001. Obviously, we could rename that to whatever we want, but we're just going to go ahead and keep it as a default name. We just need to make sure we use these names in code when we actually adjust the script file. Before we jump into the actual Lua script, though, let's go ahead and add the reference to our camera in our level flow, because the camera has an animation, and we want that animation to play when we press the control key on the keyboard or a button on our Xbox controller or whatever the case may be. So I've got my animated camera selected. I'm in my level flow here. I'm just going to right-click and choose Add Node, create the camera unit there, and then I'm going to tie this to an animation clip, reset, and play. And we're going to specify the animation that we want it to play. And in this case, it's called Animated Camera. We'll just select that. So my flow is basically set up here to where when I press a button on the keyboard or a button on an Xbox controller, it's going to play that animation that I created in 3ds Max for that unit. And this way, it will simulate the movement of the roller coaster cart. So let's go ahead and open up our Lua script file now. So we'll go to Script, Lua, and we want Project. All right, so now that we're in project.lua, we're just going to go to the local variables section of our script file. All right, so we're going to create two local variables here. We're going to create a camera unit variable and a camera node variable. The unit variable will represent the entire object that has the joints for animation and whatnot. The camera node variable will represent just that camera node. So we'll do local camera unit, and we'll initialize it to nil, and it will do local camera node also initialized to nil. Now we'll jump down to our get player start pose function, and here we'll add just 2 lines of code so we can get the pose of the camera. So local pose. Remember, pose is both the position as well as the orientation. So local pose equals stingray.camera.world_pose, and it will need 2 variables here, camera node, and the index for that camera node is 1. Okay, and then or those parameters, I should say, not variables. And then we're going to just return that pose. So return pose. And we're going to be calling this function every update or every tick so that we know exactly where the camera is currently at and what direction it's facing based on its animation. So we'll scroll down to project.onLevelLoadPreflow and scroll down towards the bottom. And right before the line that says if Oculus VR system is enabled, we're going to add our code here. So we're going to, first of all, we're going to need to get a reference to the camera unit. So we'll do camera unit equals stingray.world, and you're going to find a lot of this familiar from the previous tutorial, dot unit by name, a reference to our level, simple project dot world, and then of course the name of the camera, and this camera is called animated _ camera. And remember, that's the name of the camera from the Explorer inside the actual level editor. Okay, so now we have a reference to the camera. Now we'll need to get essentially a reference to the camera node. So we'll do camera node, and this is the child node of the camera, equals stingray.unit.camera. And then for the parameters, we need the camera unit, which we just got a reference to, and the name of the node. And remember, that's camera 001. That's the name from the 3ds Max camera. So now that we have references to both of those objects, we can, if need be, we can rotate the camera so we make sure it's facing the direction we want. So we'll go ahead and do that here. I don't know that we need to do it with this animated camera, but if you did need to do it, we could do it like this. If you needed to rotate your camera to face a specific direction to start off with, you could type stingray.camera.set local rotation, and of course we need our camera node, we need the reference to the camera unit, and then we of course need to put the quaternion value in to do the rotation. So we'll do stingray.quaternion and then stingray.vector3. If you haven't watched the previous tutorial, you should probably watch it because I explained this line in a lot more detail. And so we're going to rotate around the Y axis, so 0, 1, 0 for our vector 3. And then we need the amount of rotation in radians, so 3.14 or pi, which would basically rotate it 180 degrees. All right, and so that's all we need here. Again, this line may or may not be necessary, but I'm going to hit, just for consistency, keeping this line from the previous tutorial. And just watch that previous tutorial if you want more details on how this line is put together and why it works. All right, so now we're going to scroll down to our project update function and do the last bit of code here. And this is where every tick this update function is called, and it will update the location of our VR tracking space to match the animated camera. So first of all, we're going to do a local variable here, player start pose equals get player start pose. And that's calling, of course, the function up here, the get player start pose function, which returns the position and orientation of the camera. All right, again, this is also explained in the previous tutorial video, Lua Tips and Tricks Episode 2. So check out that video if you want more details on how this is working here, how this is put together. That's why I'm not going into too much detail on what's going on here. All right, so our last line, Oculus VR system.set tracking space pose. Now, this function, set tracking space pose, has actually been updated, or rather deprecated, in Stingray version 1.8. In Stingray 1.7, you use set tracking space pose. In Stingray 1.8, I believe instead it just says to use set tracking space, so eliminate the pose part. We're going to go ahead and keep it for consistency's sake, since the tutorial I did before this uses the older version. But if you want to go ahead and use the new Stingray 1.8 version, just be sure to eliminate this last part here. All right. And you can read, of course, the release notes for Stingray 1.8 and then just do a search for set tracking space and it'll explain the deprecation there. All right. But for consistency, we're going to keep it like this. And of course, we need two parameters for this function. Our VR system, reference to the VR system, and then our player start pose variable that we just defined above. Okay, so assuming we have no typos in our code, let's go ahead and test the project out. I've got my Oculus headset here. We'll make sure to save the level. All right, so you can see that the camera is not facing the correct direction. So if we wanted to fix that, we could easily go back into the code and make some tweaks so that the camera will be facing forward. Let's go ahead and get started here. All right, so there you can see, if I press the control key, it basically, let's go ahead and hide the UI. It plays the animation from 3ds Max. And that's a little fast, obviously. I'd want to go back in and tweak it and make it slower and maybe adjust the path on the track. But as you can see, it's working and I can look in any direction while it's going as well. All right, so that is the second way of animating a VR camera that is moving through the level. And that would be using a previously animated camera that you put together inside of 3D Studio Max or Maya and then exported into Stingray. Now, obviously, if you want to use this technique and you have an object that also animates, such as in this case, we have a roller coaster cart, you need to make sure that the camera animation also matches up with the cart animation. Otherwise, it would obviously look strange. It would lag the cart or be too far ahead of the cart, that sort of thing. So it's a little more complicated because of that. But obviously, if you just want to have a camera and you're not worried about an object that moves, this might be the better method to use for creating the effect of moving through the environment. All right, so there's one other way that you can animate a camera, and that is using the story method or using a Stingray camera rather than importing a camera that you've animated inside of Max or Maya. We'll look at that next. All right, so to use a story animated Stingray camera, we're first going to need to go ahead and create a Stingray camera. So we'll go to the Create tab, and then we can go to Camera, and we'll choose our camera here. I'm just going to pop it right here on the cart. Let's go ahead and kind of position it so that it faces forward. The great thing about using this particular technique is that by doing so, our camera will already be properly oriented because it's a Stingray camera that we're placing here. Okay, now we need to go to Story and animate the camera. But first, let's go ahead and make sure this camera has a unique name. So we'll call it My Camera. Okay, and then we'll go ahead and open Story by going to Window, Story Editor. We'll create a new story. And in this story, what we want to do is basically animate the root transformers of our camera, mostly position and rotation. Obviously, scale is not important. So we'll select position and rotation, and we'll go ahead and create a new key. Then I'm going to turn on Auto Key, and we'll move it to the end of our timeline here, about 10 seconds in this case. And we'll just go ahead and move it forward. So we'll switch to local transform so we can make sure we're transforming this camera along its local axis. All right, let's just pull this along the track. I'm not going to worry about lining it up too perfectly as this is just a demo. All right, so now if we scrub our timeline, we can see we've got an animation here. Short and sweet. All right, so now that we have our story animation, let's go back into level flow. All right, so inside flow, we just need to add our level story here. So we'll choose right click here and we'll choose add node, and then we'll go to level story. All right, and we're just going to do the same thing here where when we press the control key on the keyboard, we'll just go ahead and play the story. So we'll tie that into play. And then we need to make sure we choose our story. So let's click the button next to story. And here's our story. It's named story, oddly enough. All right, and that's all we really need to do in flow. So now we're going to jump over to the Lua code and add the lines of code we need to make it all work. First of all, let's go ahead and save our level. All right, and we'll load up under, again, script Lua project. All right, so again, in the local variables section, we're just going to add one local variable here. We'll call it local mycam equals nil. We'll initialize it to nil. All right, so in our get player start pose function, we really just need two lines here. So we're going to do local pose equals stingray.unit.world_pose mycam. That's the variable we just created, which will hold a reference to the camera, comma 1. All right, and then we'll just do return pose. All right, and then we can scroll down to the on level load preflow function. And again, in the same place from before, we're going to add one line of code this time. And it's going to be getting a reference to the camera. So mycam equals stingray dot world.unit by name, a reference to our level, so simple project dot world, and then the name of the camera. So we'll put that in quotes here, my camera. Now we'll scroll down to our update function, and we'll add 2 lines of code here to do the update every tick. So local player start pose, nothing new here, same as before, equals get player start pose. All right, so we're running that function. And then, of course, we need to update our tracking space for the Oculus. So Oculus VR system dot set tracking space. Again, you could use the 1.8 version here since this is deprecated, but for consistency, I'm going to use the old version. So set tracking space pose, and we need our 2 variables being the VR system reference and our player start pose. So not much different than the previous version. The scripting we wrote for that version, just slightly different here. But in this case, we'll be using a Stingray camera that has been animated with story. So unless, again, we have any syntax errors, we'll give our level a test and see how it looks. You can see this time, because it's a Stingray camera animated with story, it's already properly oriented at the very beginning. We don't have to add any quaternion rotations or anything like that in our Lua script to get it to look right. And of course, the camera rotates properly. Let's hide the UI and start her out. Now you can see here the issue is that the roller coaster is animating at a different speed than our camera. So again, this is a situation where if you want to use this technique and you have an object that is moving through your level, such as a cockpit or whatever, you're going to want to make sure that the camera animation matches the animation of that object. So that's going to take a little more work, obviously. But if this is the technique you want to use, instead of bringing in a Max or Maya camera, but animating with Stingray cameras and story, you can definitely use this technique. All right, so that's going to do it with the series, Lua Tips and Tricks on using cameras in VR, moving cameras around using the different techniques, such as a story-based animation for a Stingray camera or an imported animation on a Max and Maya camera. And of course, the first method we looked at was using a mesh object that has been animated, such as a roller coaster cart, to act as your camera in VR. So I hope you've enjoyed this little series. I hope it's taught you a lot about how to update the VR tracking space to match your camera, and look forward to some new tutorials in the future. So thanks for watching, guys. If you have any questions or comments, as always, post them down below in the YouTube video section or, of course, in the area blog post, and I'll get back to you as soon as I can.